Hello, my name is Brandon Earwood, and my team did energy efficient cloud computing. So, cloud computing is an internet based service provider. It provides different types of services to an organization's computers and devices over the internet. Users will only pay for what they use. It's similar to other utilities such as electricity or water, and the quality of service and the economic conditions are established in a service level agreement, or an SLA for short. Some of the characteristics of cloud include the application of the programming interface. So this determines what the programming interface will actually be used for and what the overall purpose of the cloud is. There's also the device and the location independence. So the servers and the local machine that the end user is using can be independent of one another. The virtualization includes the system independence, similar to something such as Google Mail, in which the user does not have to download a specific application or program. There's also the reliability of the cloud. It is easy to maintain and manage for both users and programmers. It offers high security and high performance, and it is also an agile software. Some of the different types of clouds that we can consider are a public cloud, which is open to anyone in the general public, a private cloud, which is closed off to a specific business or organization, a community cloud, which is somewhat similar to the private cloud in that it's restricted to a specific group of people, or a hybrid cloud, which is a combination of a public cloud and a private cloud. The different services that are offered by cloud can be considered in a layered approach. At the top layer is the cloud clients, which consists of things such as a web browser, a mobile app, some sort of thin client, or a terminal emulator, and it is essentially the interface for the end user. The next layer is the application, which includes things such as a CRM, an email, a virtual desktop, communication, or games, and it is essentially what the end user will be using that cloud for. The next layer is the platform, which includes things such as execution runtime, a database, a web server, or development tools, and includes all of the different packages and tools for maintaining and developing or designing a cloud. The lowest layer is the infrastructure, which includes the virtual machines, the servers, storage, load balancers, and a network, and consists of some of the lower layers, the lower levels for the software, as well as the hardware layer. Regarding some of the energy statistics, the energy needs for the general population are increasing on a daily basis. In particular, there is information and communication technology, or ICT for short, which has a huge impact on our environment and our economy. ICT makes up roughly 8% of our global energy consumption, and it is predicted that this will increase to 14% by 2020. Cloud computing can help to reduce this energy consumption and can also improve the efficiency and usefulness of ICT. Next, we can look at some of the opportunities and challenges of energy efficient cloud computing. The main benefit is that it will reduce the direct energy for the servers by roughly 70 to 90%. But one of the main drawbacks is that it increases the energy that is consumed by Google servers and other network traffic by roughly 2 to 3%. Uh, in addition to this, there's also the high levels of maintenance for the data centers, but also that the clouds are unfriendly to the environment. So to handle some of the environmental challenges of cloud computing, we can look to green cloud computing. Uh, in this case, some of the questions that we may have to ask ourselves is what sites are available, or what locations can we build a cloud computing server? What is the CO2 footprint, or what are the environmental effects that this cloud will have? Uh, do I have access? Is this going to be a public, private, or community-based cloud? And how much will it cost? What are going to be some of the financial costs for the end-level users, as well as some of the maintenance costs for the programmers and service providers? Here we can see an example of cloud computing. In the top left corner, we see an end user requesting a particular cloud service. From here, this is sent out to a green offer directory, as well as an energy information, as well as a carbon emission directory, in which case then this will request some green offer, as well as some efficient information. From there, depending on whether or not they're using a public or a private cloud, the service will be allocated accordingly. So you can see in D, the service is being allocated by a private cloud, and in E, the service is being allocated by one of many public clouds. Next, we can look at maximizing our job performance under certain power consumption constraints. So the main benefits of being able to provide a high performance computing are the invaluable role that it serves in research, product development, and education, and also that it can accelerate the market and provide a significant cost reduction and tremendous flexibility. Conversely, we can also look at having to minimize power consumption under certain job performance constraints. So one of the main challenges for this is lowering high operating costs for cloud service providers.
Hello guys, my name is Kanny Gaurav Dokania. I'm going to explain rest of the slides of this presentation. This optimize a linear combination of consumptions and job performance. We know that we cannot reduce our energy at zero level, or we cannot waste our energy. So we have to find exactly optimized solution for it. Cloud computing is one of the way we can optimize our solutions at certain limit. Power consumptions in transport represent a significant proportion of total power consumption for cloud storage service at medium and high usage rate. So for achieving energy optimizations, we have to be select appropriate job performance. How can we achieve that consumptions? There are some ways that we are using to achieve our power consumptions at certain limit. So for this one, there is a first is a scheduling algorithm. Scheduling algorithm helps to reduce. We know that we have several different kind of scheduling algorithms, such as first come first serve, round robin, but we have to select certain uh, part that is compatible with certain software for the CPU, and we can achieve this thing. Another is virtualization machine. How can this is also one of the way that we can achieve our energy consumptions through cloud computing. We know we use Google, Yahoo, and other so many website that's providing cloud computing features, but we are not aware. Whenever you open your Gmail account, you do not need to download for looking what exactly material I'm saying about attachment. You can look directly. This is one of the feature of cloud computing that it is providing by our server, and this is the benefit that you can save your money. You do not need to install software at your machine. That will also save energy consumptions for you. This okay. Auto scaling. Auto scaling is the third feature that it helps to reduce our energy consumptions. Auto scaling helps you to predict how you should use that particular software. It helps to reduce traffic and handle traffic in proper way, and help to plan provision resources in advance of them. It sometimes it also help your balancing your load. We know sometimes we unable to open certain website, we unable to use certain resources on internet. Why? Because of load and huge traffic for certain software. This auto scaling help us to find it out, and we can distribute that load to others ways, and we can handle it properly. Also, if we have underload, we can also find it out and we can track through auto scaling and we can manage it properly. This is one of the solutions. As we know that cloud computing gives so many benefits, but I'm going to explain some benefit that is good for our environment and we generally use. Like, if we use cloud computing, definitely we will reduce our energy consumptions. That if you reduce energy, then our energy will available for longer time. We know energy never create nor destroy. That's a concept. Equipment efficient. For if we use the cloud computing and we are trying to improve our equipment efficiency, that can reduce our energy bill, energy consumptions, and that's also benefit for environment. Dynamically allocate resources. We know sometimes we are not able to use all resources that is available to us. So how can we use efficiently that we should not waste our resources? Cloud computing is a way that helps to know how we can use our resources. Consolidate climate control cost. Also, if we reduce our uh, carbon environment and climate would be good, we do not need to waste our money and for improving our climate. This is also benefit from cloud computing. Benefits, some more benefits. The indirectly directly it comes. If you use cloud computing, it helps you to reduce your money bill. On how? Like, definitely your bill will be reduced, your money will be reduced. Suppose the clouds provider will get the less bill, it will definitely get benefit to their customer for saving their bills. If we use the another benefits, if we use less energy, it means we are producing less carbon in environment. That will help to reduce your carbon footprint. And we know at present situation we are facing greenhouse problem in environment, and cloud computing is one of the good way. As we know that all not all the solution is the perfect. Each solution has some issues, and our researcher and our scientists are working on it to achieve that goal. When to migrate VM virtualization machine, like we have a issue that overload detection algorithm, underload detection algorithm. It means that sometimes at virtualization machine we have high load of using for certain software. Sometimes we are not using that software for a long time, that's underload. It means we are wasting that resources. This is the issues on VM that we unable to find at all the time. How, which algorithm we have to select to get exact and good resource availability on the VM. This is also issues. Where to migrate. This is also problem with virtualization machine. So our research and scientists are working on it to find the solution exactly. Complications, another complications. Even if we know auto scaling help to reduce our traffic, but there's some problem that which approach we have to use to find it. Like, how can we reduce our load and traffic? There's so many ways, but which ways is good for certain software? Even though in scheduling algorithm is also good, but as we know our knowledge, we have various kind of scheduling algorithms such as FCFS, round robin, SGS, but we don't know which algorithm we have to use for certain software. We face this issue sometimes. There's a huge potential risk that stored information could be compromised if proper security measures aren't taken. We know even if we are taking so many security approaches for saving our data, still we losing our data to unknown unauthorized persons, because in cloud computing we are giving our confidential data to third party. That's a big deal. In conclusion, we can say energy efficiency lead to reduced power consumption and enhanced performance. As we know, uh, from last few slide, we can see that we have this is our goal to reduce power consumptions. Green cloud computing is envisioned to achieve not only the efficient processing and utilization of computing infrastructure but also minimize energy consumptions. Migrating to cloud can also produce estimated energy saving, which may have a substantial impact on the global economy. In comparison, we must include the energy consumptions required to transport the data from user into the cloud resource and back. These are the few conclusions that we made in through all the slides. Still, we can say that green cloud computing helps in to green our environment. That's the main concept for producing clean cloud computing.